So moving on to part 3, which is the final part of the hard communication protocol, we'd like to focus on wireless hard communication. We have since discussed that the traditional hard network or field bus, it's built on top of the analog loop wiring. Now, beyond the traditional hard wired network, there is also a standard for wireless hard network. So a wireless hard, it's a mesh network, and it's available in a release document which is called Wireless Hard Release 7. One distinctive difference between wired hard and wireless hard is that the wireless hard implements the network and the transport layer, which are not there in the wired hard, because the wired hard only implements the physical data link as well as the application layer. So the wireless hard is built to be secure, reliable, and robust. It's based on an IEEE standard 802.15.4 within the ISM band, which is the 2.4 gigahertz band, and it has a transmission speed of 250 kilobits per second, which is much faster than the wired hard, which has a speed typically of 1.2 kilobits per second. The advantage of wireless hard over the wired hard is that it lowers cabling costs because there is no need for cable. It provides a way, it's easier to install. Devices are easier to install because then there's no need to route wiring. So devices can be installed in much more environmentally difficult position. It also offers flexibility because a device can be moved around since it's wirelessly connected. So typically the wireless hard network would connect to its wired hard counterpart. So what would happen is there would be a host application or controllers on the wired network, which will be connected via a wireless hard gateway device. The device will be managing the network, the wireless part of the network, using the network manager and the security manager, and it will connect to the wireless part of the network via an access point. So the access point will connect to all the wireless hard field devices, and some of the wired hard field devices can also be connected using a wireless hard adapter, and the network can be extended using a wireless hard router. So this creates a mesh network where even mobile terminals can be connected. Now, talking about the different elements of the network, is that normally this gateway device is found in practice, it's found together or bundled together with all of these other devices. So you can find a gateway device which also contains access point functionality as well as the network manager and the security manager functionality, all in one device. So a network manager in this case is the heart of the wireless hard system. It's a software application effectively, and it is used to manage the connection of new devices for forming routing paths, so the connection paths throughout the network. It creates a communication schedule. It tells each and every node when to communicate, and it monitors any changes in the network. So any new device that needs to be connected will have to be recorded by the network manager. Any new devices which leave the network will also be recorded by the network manager. The other important aspect is the security manager, which is also a software application, and it controls access to the network. It ensures that there is secure transmission of data through the use of authorization key and encryption. What is important is that there can only be one security manager in the network, and even though multiple security managers can be able to serve, a single security manager can be able to serve multiple networks. So moving on to another type of element, which is the wireless hard field device. So this would typically be a battery powered or low power device built in with the capability of communicating on a wireless HART network, and it should be able to relay data within the network in the form of using radio frequency communication. And should there have been a wired HART field device, then the wired HART field device can also be connected through a wireless adapter and still be connected through into the wireless network. Normally, this can be done also to provide a redundant path, communication path for a certain field device. So a field device can be connected both to the wired HART and the wireless HART at the same time. The router, on the other hand, is used to extend the coverage of the network. So you can put a router. If the network is weak, then the router will extend the range at which you can connect devices, and it will be used to forward the messages to and from the remote devices. So occasionally then the system might have a mobile terminal which can be used for commission or monitoring or maintenance purposes. At the physical layer, we have already mentioned that the network is based on the IEEE 802.15.4, communicating at the 2.4 gigahertz ISM band. ISM band, remember, these are instrumentation, scientific and medical bands, which are free, which are unlicensed effectively by throughout the world. And the communication uses 15 of the possible 16 frequency channels. So there will be 15 frequency channels, and the 15 channels are all used all at once. So any two devices which are communicating can use or multiple devices can use all of the frequencies at the same time. So what normally happens is the communication will be in one frequency, and then the next communication will be on another frequency, then other following communication will be in the next frequency, and so on and so forth. So the system will hop through different frequencies as communication takes place. So in this case, we say it uses the frequency hopping spread spectrum technique, and this avoids signal jamming, because in case, let's say, one of this channel has been blocked, or there's a lot of interference here in this channel, then it means then that some of this other communication which is carried out not on the same channel, on that particular channel which has jumped, then can be able to continue. And also channels which have a lot of collision can be blacked out, so that as the system hops to multiple frequencies, it avoids that particular frequency. So this tries to build in robustness into the network. At the data link layer, the wireless HART network is the CSMACA protocol, as well as TDMA for arbitration. So CSMA is carrier sense multiple access collision avoidance, and TDMA simply means time division multiplexer. So what it simply means then is that each communication is allocated a slot. So time will be allocated a slot. So say in slot number 3, then node 1 with node 16 are communicating. In the next slot, then node 6 is communicating with node 5, and so on and so forth. So the network manager will create all sorts of slots to schedule communication there. Then what happens is that the receiver and the transmitter, the receiver will transmit information when its slot is when it's time for it to transmit at its particular slot, and then the receiver in the same time slot of 10 milliseconds, it will acknowledge receipt of information. And this ensures that the network is reliable in that sense, that communication is collision free, and it also speeds up communication. One other aspect of the wireless HART was that, remember, we have discussed that the network manager is responsible for managing devices as well as connecting new devices in a network. So how is the network formed? So typically what would happen, a network manager will have a network ID as well as a password, and each of the field devices that's placed on the floor will have been configured with a network ID and the password similar to the network manager. Now, as the device is being placed into the network, Then the device will read an advertisement from the network manager to see, and will sense that such a network that it has been configured with is available. Then it will publish a join request, which will go to the network manager. Then what will happen is that the network manager will get all the authorization from the security manager, and it will authorize the new node give it the key from the security manager, schedule its communication, give it a TDMA slot, and also assign it routing paths so that it can only communicate with that or via that particular path. And then this information will be forwarded back to the newly connected device. And now after that, the field device, once its slot comes up, can begin to communicate its own data. So at this stage, we have come to an end of hard field device. I would advise you to look at the tutorial, which will be uploaded online as well. We have looked at field bus technologies at this time generally. We have looked at hard network topologies, hard communication modules, the protocol stack of hard. We have seen that in fact the wired and the wireless aspect of hard types of hard networks are slightly different in terms of the OSI model. We have seen the benefits of hard communication when compared to the traditional analog communication. We have seen the issues of installation related to installation of hard, how to calculate loop resistance as well as how to calculate voltage ranges. And we have seen the different types of intrinsic safety barriers that can be implemented. Lastly, we have discussed wireless hard network. So make sure that you attempt the tutorial questions which have been uploaded.